Okay, sure. Thank you. So yeah, we are here to for an introductory session to blockchain. Uh, what blockchain is? I'm pretty sure in the recent times, all of us have heard about blockchain. Can anyone just speak up what they know about blockchain? Like, what do you think blockchain is? Divya, the next slide. Anyone?
What I know is that it's basically a ledger in which you can store values, and it's only write only, so you can only write things and you can't like remove things from it. So once it's in the blockchain, it can't be removed.
Okay, so that's how blockchain works. Okay. But what blockchain actually is a cryptographically secure chain of blocks to store data, to store transactions. What do you call to store transactions and all, and it has developed into something that is not just related to the currency system, but also has a development role in it. Someone is trying to get in. So, a brief history about how blockchain came into existence. Uh, so, this dates back to the year 1998 when a computer scientist named Nick Szabo he worked on a paper called Bitcoin, which was his idea of a decentralized digital currency. In the year 2000, a scientist named Stephen Const published his own theory of cryptographically secure chains, and he presented what would be the ideas of implementation of the blockchain. So, in the year 2008, the world saw a major crisis of the Lehman Brothers. So the Lehman Brothers were a huge banking and investment uh, company or corporation back in the day. So like they had huge debt. They had a debt of around $600 billion. Although they had assets more than they had the debt, so technically you could say that they could sell their assets to cover their debts. But what happened was their debt was more urgent than they could sell their assets with. Uh, Selling their assets took a lot more time than the time that was available to pay these debts. So, as a result, there was a total financial breakdown, a global economic financial crisis that was started due to a single point of failure of the Lehman Brothers. So you can see with this example that how big an impact can a single failure could have if you relied upon it. So this crisis was something of an eye opener for the centralized system of banking. People thought that a single point of failure over here resulted in such a huge global financial crisis. So why don't we design something that can, in a way, tolerate these kind of attacks or this kind of bankruptcy filings, or there shouldn't be a single point of failure. So shortly after this, an entity, I should call it, an entity called Satoshi Nakamoto. Now, no one knows who this was, if it was a particular person or a group of people. They worked under the name of Satoshi Nakamoto. Now, there are a lot of people who claim to be him, but there is no identity. They came up with an idea of Bitcoin, which was a peer-to-peer electronic cash system. So all these technical terms I'll be covering up in a while. So Satoshi Nakamoto proposed a completely decentralized approach for peer-to-peer payments. without any central entity meddling in between. Like there were no intermediaries between the transaction between you and me. I'm the payer and you are the recipient. So he like presented a paper, uh, like he or whatever the entity named Satoshi Nakamoto presented a paper in which they outlined the principles and functions of what would be developed and introduced as the Bitcoin in the next year. So this led to the invention of something called Bitcoin. Bitcoin was the first major invention in the field of blockchain, and since then Bitcoin, that used to be just a transaction system, has now separated from just being focused on the currency, and now its potential for other financial and inter-organizational transactions is being explored. So what people call is a blockchain 2.0 is formed, referring to the applications that are beyond just currency. For example, the Ethereum blockchain system, it introduces the computer programs into the blocks, like using blockchain to actually develop applications. Yeah, decentralized applications, known as DApp. Uh, is there a doubt, Aditya? Decentralized DB? No. Okay. So that was that was a spark for the decentralization to come in, and since then a lot has been researched upon, a lot has been implemented and developed in the field of uh, blockchain. So my purpose is for you to understand these blockchain technologies, and it will be a series of 5 sessions based on some crucial components uh, that actually form the Bitcoin technology. So, uh, the slide, if you can see, there's an elephant. So you might have heard the parable of the blind man and an elephant. If anyone doesn't know about it, it's a folktale about 6 blind men, and they try and describe the elephant based on their own like touch or feel of the animal. So if someone touches the tusk, they think of it as a like a monster or something, or someone touches the leg, they think that it's a giant or something. Someone touches a tail, they think it may be a horse. So if you if you cannot see something, you try and interpret it. So here is what we interpret about blockchain, or let's focus on something primitive, that was Bitcoin. So the fundamental concept of it was to build a blockchain network, a shared public ledger. A ledger means a distributed what do you say? Hello?
Yes, yeah, sure, can hear you.
Yeah, yeah. I think the screen froze. So yeah. So ledger, it means what do you say? A collection of, say, financial accounts transactions. So it's a distributed ledger. Instead of there being a single entity that knows everything, we distribute the knowledge to everyone who uses our blockchain network. So, as Ananya said before, these records are immutable. Like once they're on the decentralized network, they cannot be changed. And there's a reason behind it, to uh, prevent people from forging the transactions to for malicious activities. That is the reason why they are immutable. So, like blockchain, what do you say, it's like a new elephant to the digital world. Okay, so like for many people blockchain is nothing but like an pseudo synonym for cryptocurrencies, including Bitcoin, Ethereum, and more. So like what does it look like, what does it actually work, where can we use blockchain? I will be brushing up upon these technologies. So, uh, if you can go to the next slide. So, like, what is blockchain anyway? Like, it's a new architecture and a new trust protocol. So, it's what is it's a peer-to-peer system where there is no authoritative figure. So what does it mean? Suppose you're playing a game, let's say you're playing cricket, and there was a single guy who was keeping the scores. Okay, now that guy has to leave for some reason. He has to leave. Now what happens is the data is permanently lost. So like no one else knew the score. So the other team might quarrel that they had more runs. The team that is bowling might quarrel that no, you didn't score that run. So it will be such a mess. On the other hand, think of it like this: what if everyone knew what the score was? So like even if the umpire left, all the other 22 peeps over playing cricket over there would know what actually the score was. So there won't be any dispute. Even if there is a so I hope I make it clear that even if there is a single point of failure somewhere, there are a lot of nodes that have the data that was stored in the damaged node. So there is no virtually data loss. So it's very what do you say, very secure network in terms of it. So as I what presented before you, the Lehman Brothers, what happened was the Lehman Brothers had too much authority with them of the market. So when they failed, it led to a global crisis. Suppose you go in a bank. Okay, so your transaction, and there are a million of other people who are using the same bank as the one that you are using. Okay, so what happens if suppose the state bank failed? Suppose their network went down. So what would happen is a global uh, it would be a huge mess for everyone. On the other hand, think of it like this: there wasn't a single server that was supposed to be malfunctioning. There were a lot of servers which had all the data. So what would happen is, even if that server was damaged in a word, so even if that server was damaged, there were a lot of other servers that could have easily replaced it. So that is the main reason why decentralized applications are in such a hype these days. The next screen, please. Yeah. So some pillars of blockchain. So like it's basically a P2P transaction model. P2P means a peer-to-peer transaction model that can enable two parties to transact in a way that is like cryptographically proven to be tamper resistant. Like you cannot cheat your way into transactions. People have spent a lot of time in designing networks like this that I mean, people do find a workaround, but it's like a community of people coming together to develop something instead of there being a single entity that has to do stuff. So it's like an open distributed ledger as I defined before, uh, distributed ledger that can be simulated like uh, that can be used simultaneously and then shared with a large decentralized network that can be accessed by anyone. So you get a lot of transparency behind the scenes. Suppose think of it like this. You know that suppose there was a flood recently in Kerala, I guess. What happened was there was a lot of fundraising campaign. uh, I'll do one better example. PM Modi Care Funds. Okay, so a lot of people did contribute to it, did make their donations. But what happened to those donations is still a matter of debate. Like no one knows what happened to it. Think of it this way: if all the transactions that you made were stored somewhere and was publicly available to everyone, like what happened with those transactions, the entire history of the use of that transaction is stored in a blockchain. So think of the scale that it would affect the transparency. So like even if you contributed 10 rupees, you'd know where that 10 rupees actually went. Instead of like blindly believing someone, you can actually see. And that is in a sense like why blockchain is considered to be a future of the database and transaction systems. So what it works is, okay, the internet infrastructure as it is, and then the pillars of blockchain, which are cryptography, peer-to-peer network, and the consensus mechanism, and they all like provide a base to the for the distributed ledger to work perfectly. Now, before I move further and say a lot of technical things, I would ask if you have any doubt, put it in the chat section. Anyone, anything? Yeah, we'll cover what the technical terms actually are in a while. The Hello. Yeah, I was frozen again. Okay, so Divya, what is the meaning of peer-to-peer? Yeah, peer-to-peer. Have you ever main difference between Bitcoin and Ethereum? Okay, so yeah, first over Divya's question. Peer-to-peer, like computing, is like the workload. Suppose there's this huge network, huge task assigned to you. So you distribute them to all the networks, all the machines that are in your network. So all the peers make use of their resources to compute this thing, and in the end, you have a final result. Suppose I have a task today and I distributed it to six people, and it had six parts, and I distributed it to six people, and all of the six people worked on it and then collectively returned me the result, and I created a final thing, a final transaction, so to say. So, yeah, that's the meaning of peer-to-peer uh, model basically. And yeah, anyone can access it. Like okay, what's the main difference between Bitcoin and Ethereum? Ethereum was, so to say, made out of Bitcoin. Bitcoin is uh, Bitcoin was okay. Bitcoin was what do you say? It was more financially related. Like all it covered was transactions, transfer of money, and those things. So what? Yeah, it was it was related to that. Like it was online currency. It is an online currency, and uh, like making transaction possible over a blockchain network. And Ethereum is something like they've developed. They have a more broader vision of blockchain. So over using Ethereum, you can make decentralized applications. Like Ethereum makes it possible for your YouTube app to be decentralized, so to say. So like all the applications that you think today, if they are centralized, and if you make them decentralized, and that is the vision of Ethereum, to make the apps that are there today decentralized. So Bitcoin is like more related to currency and financial transactions, and Ethereum is related to the development side. And what else? Can you explain cryptography? I'll try to in further sections. Yeah, NFT is not based on Ethereum. Ethereum is a separate blockchain itself. Non-fungible tokens are units of data that are actually stored on the ledger. Ethereum is a network. In main system we have. Uh, okay, I'll. Okay, cool. I'll address them later. So, I've been speaking a lot like transactions, block, decentralized network, consensus protocol, and you've probably heard about mining. So, what these terms are, let me explain it to you. So, a transaction is like a value transfer between two parties. So, suppose yeah, just stay on this page. So like it could be transfer of money, assets, or cryptocurrency, anything. So transactions are like they are so to say a broad way of including stuff that you can do on a blockchain network. So like it can be anything, and transactions are then broadcasted to a blockchain network, and then they are validated by certain miners, and then once they are validated and verified, they are connected to the blockchain. And yeah, and once like it is in the blockchain, then it stays there forever, like yeah, until the blockchain is maybe uh, dropped away or something, that transaction would be on the blockchain. Even today, you can see the first transaction that was made on the blockchain network by Satoshi. And like what a block is like where all the transaction records are stored on the network. So it has certain parts that I'll explain, namely like a header and a body. So like header contains the hashes of the previous blocks. So these blocks are connected in a chain. So what happens is the block in hand has the block address of the previous block, and the block next to it has the address of the block that is with us. So in that way, they sort of form a chain. So you can access all the blocks using the hashes that are stored in the current block. So yeah, and the body contains the like a timestamp and Merkle root and stuff. We'll get onto it later. So a chain of block is formed using all these blocks. So all these blocks are linked together using a cryptographic hash. Like uh, like suppose me, Shubham, Ali, and Pallava standing. So if you ask me, then I'll know what is Ali's address. So you can go back to Ali, and then Ali would know the address of Shubham, and then Shubham would know the address of Pallav, and you know this sort of forms a chain, and that's why it's called a block and a chain. So you combine these two words and you form a blockchain. And a decentralized P2P network, it means in which the nodes are interconnected to share the resources among each other. So yeah, without there being a central authority. And a consensus mechanism or a protocol is like a set of rules that all the network follow. uh, yes, Adi, in a way they are. So like the consensus protocol is a set of rules that like all the network the nodes in the network follow, and follow to do stuff like validating things and then making a new block. All that comes under the consensus protocol. It's basically a huge deal. It's like a constitution for a blockchain network. And mining is like the process by which the nodes are like are added to a blockchain. And yeah, so someone asked about decentralized P2P network, right? So we'll go into it now. The next slide, please. Yeah, the next one. Okay, so think of it as a normal centralized banking network. Suppose there's a customer and he needs to pay, let's name them A and B for better convention. So, like a customer A needs to pay, suppose 10 rupees to B, and both of them have their accounts in the same bank. So, as of now, there are like maybe two ways to do this. Either you do it online or you go to the bank and then access the bank's web portal to do it, right? So you go to the branch and tell them that I want to send the money to B. So the thing is, you have to go to a central figure and do stuff. Okay, so in this diagram, you can see that A goes to wait a second. That A goes to the bank, and then the transaction that is being done is stored in the bank's general ledger. So ledger is like suppose a drawer of documents. You can take it for an analogy where all the transactions are being stored. Okay, so the record of this transaction is stored inside the ledger, and then this ledger is then the bank processes the ledger and does the transfer to B. So it seems pretty convenient, but if you think of it like this, what happens if someone gets access to this to the place where the ledger is stored? What if it goes in there and damages the system? So all your records are lost. Suppose Alice was paying not 10 rupees this time. Alice has paid 1 crore rupees to Bob. And now what happened is when Alice was paying, suppose the ledger went down. Someone hacked it. Someone destroyed it. So what happened is Alice's the transaction is gone. Alice doesn't have something to prove that she made a transaction to Bob. So the central point of failure, how big of an impact can it have? So bank these days, like they moved from a single ledger to a distributed ledger. The next slide, please. So the even in this thing, assume that Alice paid something, and even if there is a distributed banking network, there is still a single authority that has the hold over it. There's no transparency in that. So whatever is happening within the bank, only the bank guys know it. And even in this system, a company cannot buy a lot of databases, right? There's a limit to it. So even if they have 5, even if they have 6, 7, 8, suppose servers over the world, and if you have watched Mr. Robot, you know that even 13 of the databases were destroyed in a single attack, and all of the transaction was gone. So that is the main reason. Even if there's a distributed ledger, but a single point of failure can lead to what do you say, a large amount on the entire society. So these failures could come from anywhere, like system failures, or maybe someone attacking your network itself, privacy breaches, etc. So the root problem with the traditional currency was that there needs to be a trust between you and your bank. Like you need to trust the bank to actually you need to put your money in someone's hand and then basically trust them that they would do nothing malicious with it. Trust that they have a good system, and there won't be a point of failure. Now this trust can be a huge, what do you say, a huge blow to your head when there's a situation like the Lehman, what happened with the Lehman Brothers. investment system. So they crashed the entire market because there was a single point of failure, and consumer have to trust the bank to manage their money. But like history has shown that this trust can be breached. So can you move ahead to the next slide? This is a decentralized banking network. So what happens is, when to ensure privacy and all, what happens is when you pay a, suppose 10 rupees to B, A pays 10 rupees to B. What happens is this data is stored in every node that is there in the blockchain. So everyone in the blockchain knows that, okay, there was a transaction between A and B. Even if something goes wrong, there is always, like, you can only attack so many nodes. You cannot bring down entire system, and an entire peer-to-peer network. So what happens is, this is way more secure than that. Even if suppose the first server failed, the second node failed, the third failed, but there are a series of nodes that form a blockchain. So even one of them could retrieve all the information, and that is what makes the blockchain like so secure. And you don't have to basically trust a central authoritative figure to do something. You basically like spread out your data, and like in a cryptographic way, you don't basically tell them that this was the exact amount or something, but you spread your encoded transaction throughout the network. So there's like a minimal, the probability of the something bad happening decreases a lot. So yeah, that is, I hope you understand the concept of why decentralization is considered to be so much influential over the current systems. Right? Is there any doubt to it? Like, are you feeling that, okay, are you still feeling that decentralization is like something that shouldn't, like, centralization was better than decentralization? I mean, both have their no. Everybody knows that there was a transaction, but no one knows what transaction it actually is. It's all cryptographically encoded. So I'll be talking more on how the coding and encoding is done in general, but only Alice and Bob in this example, right? They are the names. Yeah, only Alice and Bob have their private set of keys. They suppose Alice encodes them with their private set of key, and then it and then Bob over there, it decodes it. So in a way, only Alice and Bob have the keys to unlock this. It's, suppose it's like this. You have a, you like wrote something in an envelope, stored it in something of a lock, and then only you and the guy on the other end has the key. And you asked everyone, like, suppose there was a human chain, you between two islands. So you pass that box around. Okay, so everybody knows that there was a transaction from A to B, but no one actually knows what transaction there was inside it, right? And then B takes it and decodes it, and like has the contents of the transaction with him. So everybody knows that there is a transaction between A to B, but no one actually knows what transaction that really is. So it guarantees confidentiality. That is the main thing, main motive behind it. I'll be covering how blockchain actually work in next slide. So I hope it will be more clear then. The next slide, please. Many are shifting, like Accenture, IBM. A lot of them are trying with decentralized systems. The thing is, they are a bit costlier to implement. I mean, they do. That is the, like I said, there are pros and cons to it. So, wait a second, just. So like both of them have their own pros and cons. So even if the blockchain network is sort of hard to implement, you have to create a lot of nodes and all, and that is the reason why like even investment banks do prefer these transactions, but the cost of making their own blockchain is something which is like which they do not prefer because it's not financially that what do you say uh, uh, what would be the word? It is not that financially acceptable to them. So it's the reason why. And the resources consumed in actually making these blocks, something you would have heard about Musk saying that it's very resource extensive. So yeah, that's the reason why they do not still prefer decentralized systems. I'll You'll know better. Okay, so the first step is actually like making blockchain transaction. So let's take a example again. So Alice sends $10, 10 rupees to Bob, suppose, and then what happens is Alice creates a transaction with like where it Alice sends a transaction request to the blockchain, like to the blockchain network, that hey, I want to do this transaction. Can you please process it to me? And then what happens is then the transaction is then why will they destroy their ancient centralized way? Okay, yeah, I'll just continue. I'll reach on that later. The transaction like is then digitally signed. Okay, I'm talking a bit about cryptography here. The transaction like is digitally signed by the Alice's private key. Okay, so Alice locks it with something. I hope you're getting the analogy. Okay, so Alice locks it with her private key and then sends it to the blockchain network. Okay, and then the receiver would have the key to unlock this transaction. How this key mechanism actually work would be the topic of our second session, and you'll understand much more then. But for now, just think of this as an analogy. Alice logged something and sent it to a decentralized network for it to be processed. Now, the second slide. Yeah. Now, like once this the transaction request is submitted to the blockchain network, there's a node that accepts all these transactions, that keeps a record that what transaction requests are being made. So that node will validate it according to the rules, according to the consensus protocol that I mentioned earlier of the blockchain network. And then if the transaction is valid, that what you like you call it a bookkeeper node. So that bookkeeper node will add it to a transaction pool. What is the actual node in blockchain? Yeah, nodes are devices that have copied the blockchain network over to them. Understood? Like in your school, yeah, sort of. But this server need not be a server. Even you cannot yeah, without a host you can like you can get a full node and to your system and then process the transaction yourself. I mean, even you can do it. So there's nothing like a like a figure handling all this stuff. It's distributed to everyone. So yeah, where was I? Yeah, the transaction pool. Okay, so what happens is when the bookkeeper node gets the transaction and it matches it to the consensus protocol, and if all the rules are being followed, then it sends for it to be processed. Okay, it's like a watchman or something. So like if you match the ID, if you know some like the rules of the society you want to go in, it lets you in. And once the if the transaction is valid, it adds it to a transaction pool. So what a transaction pool is, it like a bowl of something, like a bowl of chocolates, you can imagine it. So it keeps on adding to it, and the miners then will get to it in a minute. So just keep this analogy in mind, that you have a bowl of chocolates with you. So what happens is, these transaction nodes, the next slide. Yeah, these transactions are picked up from the pool and are sent to the processing. And processing by whom? Processing by the miners. The miners then collect like all the valid transactions from the pool, and then create something called a candidate block. And uh, a candidate block is created by it. So candidate block are potential, what do you say, are potential valid transactions that are to be added to the network. Now I'm focusing on the fact that these transactions should be valid, because uh, like there are always malicious people who try to harm whatever you're doing. So that is the reason why these transactions are so to say that is the reason why these transactions are processed so much. So after that, when the now like for creating the candidate block, these transactions are picked like in a span of suppose 10 minutes. For Bitcoin it's 10 minutes. For Ethereum, as far as I remember, it's around 8 or something, 8 minutes. So they pick up these transactions and then send it to be like to the network for it to add it to the blockchain. So what happens is, when the candidate block is made, uh, I mentioned some facts earlier, right? The it has the candidate While making a candidate block, the transaction is encrypted in it, and then the address of the previous node is added to it. Then a timestamp is added to it, and then a nonce, something called a nonce, is added to it. A nonce is what makes a blockchain network. You have heard that miners mine the block, right? So mining is basically solving a cryptographic problem for validating a certain block. So nonce is added to the network, to the candidate block, for that to be created a problem, to for create a cryptographic problem for the miners to solve. So the candidate block packages the all the valid transactions in it, and then it sort of creates the cryptographic hash of the transaction data. Ananya said that wouldn't like she said that what she actually said, let me yeah, you cannot really store confidential information. This is how it's stored, how it gets stored. The hash the transaction messages are encoded into something, and it creates a Merkle root. And I'll explain Merkle root in the later sections. Merkle root is basically something uh, you use to uh, cryptographically encode something. And then the miner node is ready for getting added to the blockchain. So once the candidate block is created, the next slide. Yeah, Bitcoin mining in progress. Once the candidate block is created, then a sort of a race starts for adding these mining network to the chain. So in centralized systems, there are dedicated software people who add transaction to the database, but we don't need that here, right? We want it's something like for the people and by the people. So what happens is, the miners now now they get alerted that okay, here is a candidate block, and we needed to added to the system. So a race is started for adding this block to the blockchain system, which is called mining. And like here, a consensus mechanism comes in. There are quite a few consensus mechanisms that I'll be naming in the later section. But like for Bitcoin uses the proof of work consensus mechanism, or like even Ethereum used it, but it has shifted to uh, uh, something called a POS consensus mechanism. So, like as I said before, a nonce is added to the blockchain structure. It's specifically added to the header, and when uh, this nuance is added and a difficulty level is set for the cryptographic problem to be solved. And thing is, when a certain miner solves this problem, and when a certain miner solves this problem, then he sort of gets some rewards for it, and these rewards are rewarded in the like for Bitcoin, the miners are rewarded with some bitcoins for actually doing their work and adding stuff to the blockchain network. And after that, the next slide. After that, the winning node will sort of say that, okay, I'm here and I've added the I have this new block, and it sends it to the rest of the network for verification. And when this block is verified and approved by a majority, so you need a consensus of the entire mechanism of the entire blockchain for a transaction to come in. So once there's good enough consensus for the verification of the node, then it gets accepted to the chain, and the block is sort of added to the chain. And like once this block is added, like the miners can go ahead and then what do you say, work on another problem. So here you can, in the slide, you can see the actually structure, what's the awake structure of how a block looks like. So there's a hash. The hash is your actual transaction details, and then the owner's public key. And once this transaction is it's broadcasted to the entire network. Okay, so suppose I'm sending something to Pallav, but I need Shubham, Ali, and Divya to actually send it to them, right? So they are all the part of the blockchain network. So what happens is, even Ali can access, if even like suppose my private key is there with Ali, and it's there with Pallav too. So even Ali can access the private key. So it's like using private key to unlock and view my transaction details. But since people are aware that they shouldn't share their keys, so the blockchain network remains secure. So all the nodes in the blockchain, you might be wondering that, okay, blockchain mein add to kar diya, what next? So it sort of, when it's added to the blockchain, anyone over the web, like anyone inside the blockchain network, can go ahead and try and decrypt it. It's encoded in a hash function, right? So you need to decrypt it, and for that decryption, you need a key. And the ones who have a key would certainly access the data from it. So in this case, since the only person that would have the key would be Pallav. So yeah, and that is how exactly the blockchain network is. Nonce is, to create a sort of a difficulty level for the actual the actual problem that the miners solve. For that, it's used to sort of, uh, if I go in depth about it, let me, like, it's basically used to manage the difficulty level of the block of the cryptographic hash function. How does it prevent malicious miners? So think of this like a treasure hunt. Okay, the candidate block that is created has a nonce in it. Nonce is the treasure that you're looking for. I don't know if you have ever uh, used hack the box or something. There's something that you need to find and submit it for a machine to be solved. So nonce is something like you go ahead, you go check the box, and if the nonce that was set by the blockchain network and the miner like solves the problem, gets the nonce, and then says, okay, this is my nonce, and the blockchain network then matches it with the nonce that it added to the problem. Okay, and if they both match, they know that okay, this block is verified by the miner, and then they take it. And now malicious miners, what they would try to do is, suppose they suppose you, me, and one other guy, we are trying to solve the problem. I actually found the nuance, but you said that no, I found some other nuance. So there's a conflict over here, right? So suppose you're the malicious miner and you have some fake nuance to it. So what happens is the nonce, since it was added by the blockchain network can verify the nonce. So once both the nonce matches, they accept it from me and not from you. So that is how the so to say malicious miners are avoided from exploiting the blockchain network. I hope it's clear, right? Yeah, Pallav, did I miss any of the questions? Okay, this was is in Ethereum uses NFT or not? I actually have to search for it. I don't really know if it uses, but yeah, yeah, Ethereum uses NFT for recording the transactions. Will main system be hacked? That's the entire point. There is no main system here. There is a system, and there are a lot of people that are that system. There is no main system to be hacked. Anyone else? Any questions? Where is all the data stored? All the data is stored in a blockchain network, and yeah, sort of works like GitHub. Someone gave a nice enough reference. So yeah, so like a blockchain network records it, and then people who, if I use the word clone, but cloned is not exactly what you do, but you have a copy of that blockchain network to you. And when like a lot of people have this copy of the entire blockchain network, entire history. So like if you if you get a full node of a blockchain, it has all the transaction details from 2008. Like if I talk about Bitcoin from 2008 to this date. Nice little rhyme, but yeah. So that is how the data is stored in the individual systems. And all this data processing and accepting new nodes and all, it takes a lot of resources, and that's like you must have heard Elon Musk saying that it's resource extensive. So like solving these cryptographic puzzles and all, it's like consumes a lot of resource. Even to run a full node on your net on your machine, you need to have a good enough GPU, a good enough RAM to support it. Like Ethereum blockchain, to copy a full node, they recommend that you should have a 32 gigabytes of RAM and about 6 GB of GPU to actually process the entire node. Yeah, IPFS would be in the next session. It's more related to web, like actually using the file system to store. Since like blockchain is immutable, right? And at a point of time you will make some certain mistakes in your request and also IPFS is for that. You can edit things over there. Are miners the only person having a career in the whole blockchain system? Yeah, they the miners, what they do is they earn money out of, like they solve a cryptographic function and they get big bitcoins for it. And talking about careers, I mean, you can be someone who designs an entire blockchain network and then sells it for to a company for to use, or get assigned by a company to make a blockchain network. So that is what blockchain developers do. Then there's like decentralized application developers who use existing blockchain networks like Ethereum and build apps upon them. Then there are miners who actually solve the cryptographic functions and like help the blockchain network to survive. Will the recent blockchain system be affected by quantum computing? How exactly do you propose? Quantum computing basically, like, all the recent progression around it are like making uh, processors that are fast. I mean, that can do stuff a lot quicker than standard processors. So data storage and all would still be an issue, but yeah. Anything else? Any doubt? What really creates a consensus? Okay, suppose you and a group of your associates uh, are working to create a blockchain network, and you sit down and write how your rules, what your rules would be for the blockchain, for your blockchain. Like you'd be using the SHA-256 or the SHA-512 coding, like cryptographic measures. How many, like, what would be the time duration of picking candidate blocks from the transaction pools, and the number of miners, the consensus mechanism that you would use, like would you use proof of work, would you use proof of stake, uh, would you use proof of authority? So all that is in the hands of the people who actually develop the blockchain network. So they create a consensus. Like Satoshi created the consensus for the Bitcoin, although it has been updated since then, but he was the guy who first did it. So, like Vitalik Buterin created Ethereum, so he and his associates would have developed the consensus protocol for their blockchain. Every blockchain has their own consensus protocol and consensus mechanisms. They trust it because they make it trustable. They make it like people can actually see the entire thing. There are no backdoors or something in that. Like it's so secure that even your data won't be destroyed. No one would access your data. You can access your data from any time. There are miners who would profit from processing your data. So like it's a sort of a win-win situation for everyone. Only if you like it is bottlenecked by certain factors like there being only so many miners to like to mine the blocks, and like if I go into mining and suppose someone over there who has a better system than mine, who has a lot of high spec computers with them, that there are specific companies that hire like people who do cryptography to mine the nodes and they earn from it. So yeah, yeah, maybe, but I mean, someone would come up with something better, but who knows? Everything develops with other things. Quantum computing is developing, then cryptography would develop with it. Bitcoin has a cap and Ethereum does not. So Bitcoin has a cap for inflation purposes. Like they made only I don't know what was the exact number. I guess there are only so many blocks that can be mined. And what happens is like as soon as the 50% of the blocks have been mined of the total number of blocks that are there at the moment, the coins that a miner gets from it would reduce. Suppose there was 50,000 coins, 50,000, what do you say, total nodes that a blockchain would have. And suppose after, at the beginning, everyone had like received 10 bitcoins for adding a node to the network. But when, after, suppose 10,000, the the amount of money that would be given to them would be reduced to what did I say earlier? Suppose it was 10, then it would reduce to 8, and so on. So like once it reaches around 45,000, then it would become so small that no one like it won't exhaust completely. So the value of Bitcoin would remain sort of stable. Like you know US dollars and Indian rupees, they fluctuate. So to handle inflation and all, that was done. Added a cap. Ethereum Ethereum uses something called a gas. With every transaction, you have to pay gas. So it's their way of controlling the inflation in the system. Like suppose I sent you 10 rupees, then I'd be charged suppose 1 rupee for the transaction. So that is how they control inflation in the system. Things like this you'd know better if you read about stuff. So yeah. Anything else? I guess no. I mean, I'll drop my mail in this. If you have any doubt, you can just mail me, or better yet, I'll give my WhatsApp number so and reach out over here. So plus, there would be more sessions in the future. So